Let's briefly look at the systematic approach to equilibrium equations. To start with, what kind of equations we have for unknown concentrations? First, we have mass balance equations. Actually, it's not mass balance, it's concentration balance equations, just traditional name. So, for example, when HA reacts with water to make H3O plus and A minus, that means that HA molecules can exist in two forms, HA and A minus. So total concentration of both forms is equal to Ca, and these are two numbers. Charge balance equations. Electrolyte solutions are electrically neutral, even so they may contain several moles per liter of charged ions. Molar concentration of positive charge in electrolyte always equal to molar concentration of negative charge. So total number of positives and total number of negatives are always the same. So for example, in a solution of HCl, there are only one positive ion, H+, and there are two negative ions, Cl- and OH-. So total concentration of H+ is equal to Cl- and OH-. In most cases, this last one is very small. Now, what other equations we have? We have equilibrium constants, plenty of them. So if number of unknown concentrations is equal to number of independent equations we have, we can solve this system of equations and find the unknown concentrations. Let's look at several examples. First, solution of HCl in water. Calculate pH of 10 to the negative 7 molar HCl. You see that concentration is very small, so we cannot just reject OH-. We can instantly say it's slightly below 7. That's good enough. So charge balance equation is concentration of positive ion equal to negative, which are Cl- and OH-. Now, total concentration of chloride is equal to total concentration of HCl. Why? Because it's a strong acid. No HCl molecules present. So we have two equations. We need one more. And this would be ionic product of water. H+ multiplied by OH- is constant, and we know this constant. So let's look at this equation. H+. Now instead of Cl-, I'm putting C here, OH-. Instead of OH-, I can put Kw divided by H+. So I have one equation with one unknown. Next, I'm rewriting it, so I'll have a standard quadratic equation like this. For standard quadratic equation, we have a simple formula. So we hook the numbers and we receive the solution for any concentration. Now, Kw is always the same, at least at room temperature. So instead of Kw, I can put simply 10 to the negative 14. And I'll have such an approximate equation showing me concentrations, total concentration of HCl, and resulting H+. So for our example, 1 to 10 to the negative 7 molar HCl, I'm hooking the numbers, and I have concentration of H plus 1.62 10 to the negative 7, which gives me pH 6.79, around 6.8. We had a very good guess at the very beginning. Next, solution of boric acid in water. Let's calculate pH of 110 to the negative 5 molar boric acid. Now, boric acid is very weak. Its constant is 5.8, 10 to the negative 10, which gives me pH 9.24. So even at this low concentration, most of boric acid will still stay as boric acid. Our quick solution will be 1/2 of pKa minus 1/2 of log C. Will give us obviously a wrong number because it's above 7. It's very close, but it's above 7. It cannot be. That means there is absolutely no H plus coming from here. It will be mostly pH of water. So our good starting guess would be pH 7, slightly below 7. Okay, let's do exact calculations. So for our charge balance, H plus will be BOH4 minus and OH minus. 2 negative ions, 1 positive. Mass balance will give me that total concentration of boric acid and its equilibrium concentration is practically the same because it's very weak. Again, this is approximation. This is not. Two more equations. One is constant of water. Another is dissociation constant of boric acid. From here, instead of OH minus, we can say it's Kw divided by H plus from constant of water. Now, instead of H3, PO3, I am writing C. As a result, I have KAC is going here, H plus multiplied by BOH4 minus. I'm putting this expression. And now I'm just calculating this H plus multiplied by H plus H square. H plus multiplied by this expression simply gives me Kw. So placing Kw to the left side, I have such simple equation. H plus square is KC plus Kw. You remember before that we simply had the same but without Kw. So our general formula will be H plus approximately square root of 10 to the negative 14 plus Ka multiplied by C. Okay, for our specific example, H plus will be 10 to the negative 14, 5.8, 10 to the negative 10 by 10 to the negative 5. It's 10 to the negative 15. So total will be 158, 10 to the negative 14. And taking square root, 126, 10 to the negative 7. And pH will be 6.9. Now, our starting guess without any calculations was reasonably good. Slightly below 7 and 6.9 looks very similar.